Man, Shashank, I don't know. I feel like every week, I think that it can't get any crazier yet. Like, every week, there's just like new stuff being released all the time. Like, it's wild.
Yeah.
I love it. I feel like we are in the right place at the right time right now. It's just like, it's amazing the times that we live in. Just crazy.
Sometimes I feel like it's too late, but then there's always new stuff coming out.
Yeah, and it's the worst it'll ever be. I feel like for those that don't have any optimism about the future, like with all the stuff that like just got released this week, I'm like having so much optimism for like the bright future that's gonna be here. So
Are you? So the first thing that we kind of wanted to talk about gives me a lot of excitement, but also a lot of fear and career anxiety because I forget the name of the company, but they released the first AI software engineer called Devin AI.
yes, well, I don't know if I would call that the first AI software engineer. Maybe they call it that. But
It's a sensationalized title.
Wow.
I think people have been playing around with this idea ever since ChatGPT came out and ever since agents became kind of popular. So using agents to loop back in on themselves to create a response, check if the response is good enough, make some tweaks, continue expanding on that response. I feel like that's basically what they're doing.
basically just have the AI code for you.
Yeah.
Yeah.
By continually refining its answer.
Yeah. I mean, it seems like an exciting demo. Although, I don't think you call it the first because I made something very similar 5 months ago. I'll link it in the I'll link it in the description. I called it GPT Engineer. It did a very similar thing, although not nearly as refined, I think, as what they're doing.
So tell me about what Devin AI does.
Yeah, so my understanding is that Devin AI will essentially try to program for you. So you give it a prompt, and then it'll attempt to, based off the prompt, write the code for you. So with it, it'll have its own kind of text editor where it'll go and actually write the code. It will, I think it'll maybe make Git commits, my understanding. So it'll go and submit the code. So like, for those that don't know, Git is a version control software. In fancy speak, it's just like, or not even fancy speak, but like to make it simple, it's just like a way of saving your work. A lot of programmers use it to make changes to code.
And keeping track of what you
Yeah, and then keep track of what you've done, and then it really makes it easy to like kind of share it, and then like undo what you've worked on. So, anyways, it has a text editor where you can write the code. It'll make Git commits for you. It will also have a browser where it can go like look up the documentation for the code. I don't know. I think it'll also try to run the code as well and try to debug it as well. So that's my understanding is it just kind of does the entire development workflow in an automated way, which seems cool. The video that they had looked impressive, but then again, we don't have a lot of details. So it looks extremely exciting and looks far better than when I created like in a weekend 5 months ago. But with that being said, it's not open source. It's not available yet. I don't think anybody can use it. The only thing we have is a video. So they may have actually gotten something really good working, but until like I'm actually able to use it and get my hands on it, like I don't think I have like a solid opinion on it yet.
Yeah. So let me try to set the stage a little bit. So in comparison, people today use Copilot, like Microsoft Copilot or GitHub Copilot, or maybe ChatGPT directly to help them program, spit out chunks of code, maybe help them debug something that's broken, paste it an error message, or give it a snippet of your existing code base, ask it to make some changes. And on coding benchmarks, all of these models are really, really bad. They perform, or maybe they pass about 4 to 8% of the coding tasks that a human can perform. And Devin is a big step up, but it's only about like 13 or 14%. And like, if you wanted a project done, you're not going to hire someone who can do only 13% of the work. But this is a cool opportunity to maybe have Devin run with all the low-hanging fruit that's there in your project and try to, fix some of the small typos, maybe like upgrading from one version to another, which is tedious and pretty straightforward. And that kind of is exciting because, that takes up time from developers to maintain, fix small things, context switch. So if it can handle some of the low-hanging fruit, I would call that a win. And looking at their demo, so they've built a lot, like you said. They have their whole environment, which is kind of like an IDE, which is a fancy code editor, text editor. They have a terminal. They have their own environment, I assume, maybe running on some of their cloud servers that's running their code. And they have the most powerful tool that most developers use, which is Google to like figure out what this error means or look up some documentation. So if you give it a task and it's like, okay, I can solve this task using this framework or this API, it'll Google that framework's API docs, read through the entire documentation, and figure out exactly what functions to call, what framework APIs to use, puts that all together in its code base, runs it, and like looks at some errors, tries to debug it. I mean, that's pretty cool. But like you said, it's not that novel because you said you built something similar, right?
Yeah, I mean, I guess maybe I'm like hard to impress because I was like, oh man, with ChatGPT, it can write code. Oh, why don't I have it try to debug the code and have it run on my computer? Like,
yeah, what did you build?
So what I built is a thing that will kind of simulate all of the functions of a company.
So it's an agent, right?
Yeah.
Or a collection of agents.
Kind of. Yeah. I guess you could call it like a collection of agents, right? So you could have a product manager agent where they come up with requirements. You could have like a programmer who would take the requirements from the product manager and then, write code. You could have somebody review the code. Then you could go and then have a human in the loop if you want, and then give feedback on the code. And then you could just continually iterate on that and just have like the agents calling each other. So that is what I built. It's all open source on GitHub. You can try it out if you want. It's pretty good at building some small programs. It doesn't do things like it won't open up a browser for you, but it uses GPT-4, which GPT-4 can search on your behalf.
Can it? The API?
I think so.
Okay.
At least I'm not sure, but I think so.
Okay.
And so it can do well, at least on the web interface, you can search on there. So that's what I built, and it works pretty decent. So I'm curious to kind of play with Devin and see kind of the just how it works. But I think that like let's just take a step back, right? And I think like we used a lot of like jargon, like we used like terms like IDE, like text editor, API, stuff like that, which for those who are programmers, I'm sure you're following right along, but those who are not programmers, I want to just like kind of just explain how a programmer will work and like kind of what they do on a day-to-day basis. So depending on like your level, right? So if you're a junior developer, you'll probably be working on like small tasks that like a senior developer or somebody else has given you. So for example, they might have like a small like little bug fix, or there might be a library that you're using that needs to be upgraded. Maybe you're making some sort of small feature, whereas like a senior developer, they might be doing the entire kind of architecture, like how everything fits as like a whole. So they might actually be doing a lot less programming, but they might be doing more like, hey, like, this software is really, really big. How do we kind of structure it in a way that makes sense? So we say architecture, and it's like architecture for software, and that's like very comparable to like architecture in like a building, right? So like, I'm not an architect, but I would imagine that an architect in a building would actually, say like, hey, like this is where all the rooms are going to be. Here's where the bathroom is. Here where the kitchen is. Does like the floor plan flow nice, right? The same type of analogy can be said for programming. Like, does all the code line up properly? How are we going to organize different bits and pieces, right? You're going to have like maybe the ability to do authentication to log in. Maybe you're going to have to, hold some state where you want to remember things. Maybe you want to save something to the database. How is that going to work? How is that going to look? Can you make the design any simpler? And in order to do that, what like a programmer will do is they'll typically do a lot of thinking. Just think about like, what they actually want to build. They're going to think about like maybe what technologies they want to use. They're going to think about maybe if they're going to use like any services, right? Like maybe they're going to build something on top of Google. They're going to build something on top of Amazon. They're going to build something on top of ChatGPT. They're going to use different programming libraries or frameworks. So there's ones like Python or Java. Maybe you're going to use something like React. You're going to have to figure out how to structure all the code, right? So you have to do all that. And then you have to design the architecture as well. And then now those are just like programming things. But then like you also have to help figure out and work with those who are giving requirements for it, like what you actually want to build. So like whereas a lot of software development job is like figuring out like how to build a thing once you know what you want to build, I feel like a somewhat even bigger part of software is trying to figure out and like what exactly should be built, right? Like, of the total possible problem space of things that you could possibly build, you have to select and choose like exactly what you want to build, right? So for example, Google, they started with the search product. They didn't have to start with Google search. They could have built like Google Maps first, or they could have built like a photo sharing app, but they decided like, hey, we're going to build search. And these are like the things we're going to have to do. Like, so even just like deciding like what type of product that you want based off of like the market research that you do is something that maybe like a programmer would do depending on like the size of the company, or maybe you'd have like another person work on that. And I think that like where these AIs are good is they are good at, given a hyper specific problem, I think they're pretty good at, maybe solving that. But I don't think we're at a point yet where the AI is, oftentimes coming up with like what to build, how everything fits in context, and, working through that. So like, sure, like a programmer will do the act of programming, which will be like, hey, like once I've decided on a feature that I want to build, I will go and then use something like a text editor. So like if you don't even just to describe a text editor, it's like Microsoft Word, right? Like I'm just like a place where I can type like literally text. That's a text editor, and that's like what people use to write code, and then they'll save that text into a file, and then that file is like code that can be ran. And then I mean that's pretty much it. That's like how you would like write code, but that is a hyper specific thing that you would do after you define the tasks. But like actually come up with the tasks is not something that like Devin could do yet. Although I am excited for that.
Yeah, I think that's a fair analysis, and the analogy to building a physical building where the architect designs the plans and the engineers actually build it. That makes sense. But I don't know if I agree with you saying that we don't have the capability for these LLMs to architect, design, and write the code. I think all we're missing is more loops, more feedbacks, like more error checking, more analysis of the output, and recursing on that loop to just like keep refining the output. Because like if you think about what you do as a developer, it's not like you have an idea, and the first idea that you have, you take it and you run with it. No, you sit and like have a bunch of different ideas. You sit down, you maybe intuit the pros and cons of these things, or you sit and like explicitly outline, okay, this makes sense for this certain scenario. This is better in some other cases. And after doing all those evaluations, and then you move on to the next step. And even when you're writing code, you kind of think about, okay, if I write the code this way, it makes more sense. If I think about future compatibility, maybe I should structure it this way. So imagine if you took Devin AI, let's say this AI, I don't know what to call personification of AIs at this point. Yeah, sure.
I don't know.
Let's be kind to our future overlords. They can maybe do this task for 10 times what ChatGPT's output would cost for the same amount of output. Because like, let's say it takes 10 actions for each equivalent action that ChatGPT does. This thing would look up a bunch of documentation, spit out some code, maybe like evaluate it, check the errors, and then like make some refinements. What if you up that recursion, up the number of loops that you do and refine up to like 100, 1,000? What if you spent the amount of money that you would on a senior developer at one of these FANG companies and just have it keep refining its output?
Interesting.
I feel like that could result in a really polished architecture, design, and final output code.
Maybe you need something more than Devin, because I think that, well, I don't know, because I haven't used Devin, but I would think that you might want to have something like maybe taken user feedback, for example, and then based off of user feedback, maybe try to figure out new features that you could build, or maybe based off of metrics or crashes or something like that, you could like monitor in-field production and then go and modify code from that. And then maybe you could even do something like monitor like the news stories and Google Trends and new technology that comes out, and you could try to figure out what the demand is and try to figure out like what new features to build. And I think all of that could be automated actually. And honestly, now that I think about it, now that I talk about it out loud, I think I'm with you. I think that the technology is there right now to probably automate an entire company.
Yeah, it's just about more resources. Just throw more compute, more money.
But like, would you even need that many resources to do it? I think like you could probably just like hook together some of these APIs, build some agents, and you could probably get something like, I mean, I think you could honestly just create an entire agent that just makes software companies.
Well, I think software is kind of like an art. So you can always keep refining it, maybe get incremental returns, but there's probably a sweet spot where the amount of effort that you're putting in gives you the maximum return. And I'm sure we haven't reached that limit yet.
Yeah, you know, I think that's probably true. But I think that this will make it so that it will be incredibly easy in the future, or maybe even now, to create maybe not large scale software projects, but medium-sized software projects that could potentially be big enough for a like complete company. Like, depending on the type of thing, like maybe, actually, I don't know. I can't think of like off the top of my head, like any like really small scale software that can be like a company, but
Vitalytics?
Well, that's a secret. Can't talk about that one yet.
It's a secret project.
Secret project.
We may tell you once we figure out the
Legal implications.
legal implications. Yeah.
Yeah. So,
But yeah, so looking forward, we have Gemini Pro, which you recently got access to. Maybe you can talk about that later. But with larger context sizes, maybe Devin can look through a bigger, like more files, look at more code, get more context, and keep making bigger and bigger pieces of software. Maybe we get specialized agents, like you mentioned. The problem of figuring out what to build is just as important as actually building it. So specialized product manager agents that do more thorough, maybe user research studies and business analysis and try to figure out whether or not this feature makes sense to build. And yeah.
Yeah, I think so. I mean, that sounds like a fun project to try to automate an entire software company. I have to think about exactly what to do, but
I mean, you started doing that. I think it's just about scaling it,
yeah,
throwing a lot of resources at it and see what happens.
you know, it sounds so much fun. I'm ready. Let's build that. So anyways, switching topics.
Yeah.
Gemini.
Big models.
Yeah, though, speaking of big models, I just like a couple days ago got access to the new large Gemini model. So for this
medium Gemini model, large context window.
Oh, is that right?
Yeah, because we have Gemini Ultra, which is which you get with the paid version of Gemini today. The Gemini Pro, which is the free version, and Nano or smaller ones that run on device on the Pixel phones. So I think the one that you got access to, the 1 million token context window, was the Gemini Pro 1.5. So it's the medium one. I'm not sure why they picked the medium model to experiment with this feature, but yeah.
Okay, so that actually explains a lot. Mm-hmm. So, for those that don't know, Gemini is Google's answer to ChatGPT. It is Google's large language model, and they have something that's super exciting because it's a 1 million token context window.
Oh, it's insanity,
which is just ridiculously big. So
I think the biggest ones right now have ChatGPT. I think is 128,000 tokens context window, and maybe the biggest Anthropic might have 200K.
So for reference, a token is about 75% of a word. So 1 million tokens would be about 700,000 words ish, and then the context window is basically just like the total prompt size that you can give. So just like, how long of a question can I ask?
And I think 1 million tokens is almost the length of all the Harry Potter books combined.
Yeah, so it's big. It's really big. And I have been playing with it, and it's pretty good. I am very impressed. I haven't actually I haven't done anything like too crazy yet, but I have fed in multiple books, and it does seem like it's able to comprehend the multiple books that I give it, which is cool. Although I haven't actually asked for like too many questions, so I need to play with it more. But so far, I'm impressed. It does seem very good. Although I don't think that it has as much polish as the large model that you mentioned,
the Ultra.
Yeah, the Ultra. Mm-hmm. Because I've been using the paid version of Gemini, which I think is really cool. It'll do things like summarize YouTube videos. So like you can go paste in the URL of a YouTube video, and it'll summarize it for you. You can also hook it up to your Google Drive, and it will analyze some of the documents that you have. You can it'll generate images for you. But this new 1 million token context window one, it doesn't do as all of that stuff. So like it doesn't summarize YouTube videos. I think it can hook to your Google Drive, but that's it. Like it can't, I don't think it'll generate images for you. It just, it doesn't have like all the same functionality as like the other bigger Gemini model. But so far I am impressed. And I think something like this will be the key to writing large pieces of software.
Yep.
Like, so I think like if Devin could leverage something like this, I mean, at a certain point, like, I mean, you only need the software program to be so big. Mm-hmm. So I think that like we're reaching the point where you can almost build anything you want.
Yeah, that's a really exciting prospect. And for agents too, if you have a bunch of different versions of LLMs talking to each other, working on different tasks, try to contain everything that each agent has done through multiple loops. You need a big context window for that. And I'm sure maybe there can be optimizations like RAGs, where you break down the context window and extract relevant chunks, store it somewhere, and then retrieve it later when you're trying to answer more questions. That can help reduce the amount of context that you need to keep in memory. But this makes it way easier. And I'm sure it'll expand the capabilities of these agents.
Yeah. I think we've explained in a couple of the episodes, but RAG is basically a technique where it helps you get around context window limitations. So like most of the time, actually it's only recently that we have like 100,000 token context windows. Like a lot of these models will limit you to like 1,000 tokens or 2,000 tokens. So like you're pretty limited on the total size of the question that you could ask. So RAG is a technique where it will allow you to try to, based off of, some sort of source data. So let's imagine you have a book. The book is, let's say, 1 million tokens. Well, now you can just throw in the whole book, so it doesn't matter. But when you only can enter in like 1,000 tokens, well, now you have to figure out maybe like which page of the book is relevant to the question you want. So like RAG is a technique that you could use to potentially help you figure out like the correct page of the book and then answer questions about the correct page.
Yeah, but honestly, in practice, it's not as straightforward as it seems, because building the RAG itself is kind of an art. There isn't one size fits all solution to this, because if you break down this book into separate chunks and store each chunk somewhere to retrieve later, sometimes you may miss context that's in between two chunks. Maybe there's like a long paragraph detailing some scene, and half of the paragraph is in one chunk, half of the paragraph is in another chunk. And so you have to like kind of play around with the chunking size and figuring out how much you retrieve and what you feed back in as context. So I think in an ideal scenario that works, but in practice it's very challenging to get working right.
Right. And so when we say chunking, that's just basically the problem. How do you break up the data, right? So like I mentioned that, when you think of a book, it would be chunked by page, right? But you could potentially break it up, maybe not by page, but by paragraph or by word, or by maybe some logical part, right? Maybe like a grouping of paragraphs or a grouping of pages. And then maybe, do you want to have like independent chunks, or do you want them to kind of overlap with each other? Like, so for example, do I want like page 1 and page 2, then page 2 and page 3, or do I want page 1, page 2, page 3, right? So like, do I want to overlap page 2, or like, do I want to have like individual distinct pages? So like, that's why it's a bit of an art, right? Because like, there's all these kind of questions that are somewhat not obvious, and there is like not like a single correct answer for like how you're going to break down the data that you're working with. So these really large context windows help with that problem, because like you don't even need to worry about chunking in this case. You don't need to worry about breaking the data. You just throw all the data in, and then the model just thinks about it and then is able to give you an answer. And you don't have to do any of this stuff where you're trying to figure out how can I take this like really large piece of data and then fit it into this like little tiny window. I can just use the data, all of it in its entirety, and the model can just figure it out. So that's like really, really exciting.
Yeah, but obviously that comes with the trade-off of cost and performance maybe. So the more context you give it, the longer it takes to give you a response, because it has to go through that entire context, load it in memory, maybe do some fancy matrix multiplication on it, do a lot of math, which not only costs a lot of money, takes a lot of time. So ideally, a combination of the two, building this RAG and using maybe bigger chunks and leveraging this bigger context window would help you reach a good sweet spot in terms of cost, performance, efficiency.
Yeah, that's true. I think that it really depends on maybe like the use case for, like, if RAG will be like a good tool for you, or if just throwing the entire context into a model will work. So I don't know. Either way could potentially work, but I guess speaking high level, it really just depends on the use case. So, Shashank, switching the topic a little bit, I saw this demo where OpenAI and I guess it's Figure AI, who's based out of Sunnyvale, where our meetup is. So all the folks from Figure AI who are listening to this religiously, let us know. Send us an email. Reach out, and we'd love to have you on the podcast. And or if you could give us a tour of the place where you build the robots. We just live down the street, so yeah, hit us up. But this demo is really pretty cool. Shashank, I don't know. I think you saw. What do you think of it?
Yeah.
Or can you explain what happened?
Yeah. So there's a humanoid robot that is taking instructions from a person in front of it and able to do pretty general real-world tasks with 2 of these bionic arms with very fine articulated fingers that can manipulate delicate objects. The part that I found unique with this particular demo, because I think there have been multiple robots in the past. Boston Dynamics has been around for a while. Tesla has been working on their robot.
Yeah.
But I think I went back and watched the Tesla video, and the Tesla bot is mostly focused on the engineering and not so much the AI planning, decision-making, and action-taking. Because there was a guy with a glove that was being mirrored by the Tesla bot. So it wasn't actually responding to any general natural language requests and then performing a complex action, whereas this is the only one with a sophisticated enough demo today. So you can put it in any arbitrary environment, maybe like manufacturing, and say, hey, assemble this thing. You might have to give it a few examples first, because it's just like an LLM. You give it an example. Hey, this is what I need done. Can you do it? And theoretically, it should be able to do it. So the demo showed it looking at an apple in a bucket in front of it on a table, and the guy was like, "Hey, I'm hungry. What do you see in front of you? And can you do something about that?" So the robot was like, "Oh, I see an apple. If you're hungry, here." He picks up the apple and hands it to the person. And then, he dumps a bunch of garbage on the table and asks it to clean it. So it picks it up,
Pick that up,
removes it, and puts it in the trash can. The part that I think may be overhyped is that they're using OpenAI's API to plan and make decisions and maybe give actions to this robot in some maybe proprietary syntax, but it's a big delay. It calls the API, and the video shows that it's sped up 2x.
Oh, it's sped up.
Yeah. So there's a big lag. You ask it a question, and then it's just thinking, waiting for the API to respond, and then starts responding. So
there'll be some optimizations there that might be able to make.
Yeah. There's a couple optimizations that need to be done before it's ready to ship to customers. Because if you're sitting at home, you're asking your robot to do something, and it takes 30 seconds to respond. I feel like that's not the best experience for most use cases.
Yeah. Well, I'm sure that there is some work that needs to be done. In the video, the robot wasn't moving around, right? It was only dealing with stuff directly in front of it. It'd be really cool if you could be hey, go to the refrigerator, and make me dinner, right?
So speaking of that, I remember watching a video from Google before Bard and Gemini, with maybe before ChatGPT 4. They had this thing called Palm, or Palm 2, one of their earlier transformer models, and they hooked it up to a robot that was part of their research team, and told the robot to get a snack from the kitchen. And I think the robot had wheels and 2 arms. It was able to navigate to the kitchen, open the drawer, find a bag of chips, bring it back to the person, and then hand it to them. I feel like, as a proof of concept, in the research setting at least, that was demoed a couple of years ago.
Wow. So I feel like that's actually even maybe more impressive than handing an apple.
That's a good question. I think the pathfinding issue has been a solved problem because we've had Roombas for a while. They know how to navigate your house. They know how to avoid obstacles, go around them. So
Right, but I think it's in this case it's less of like a pathfinding, or maybe it is, but what I'm thinking is like, searching for something where you don't know what it is, and it's not only just like the path, but knowing that like, oh, I can like open a refrigerator, or I can open the drawer, or like let's imagine like once like it's like, hey, make me a sandwich. It's like maybe I want a peanut butter sandwich, so it has to like maybe go find the bread, open the bag.
Before that, figure out that he needs to go to the kitchen.
Yeah,
as opposed to the bathroom.
That's right. Open up the jar of peanut butter, like grab the knife or the spoon, whatever you want, like put the piece of bread on a plate, like scoop out the peanut butter, splat it on there, cut the sandwich in half, like bring it to me. There's like so many like steps that I think are like a lot harder when it comes to like, doing something like, making me a sandwich. But like, I don't know. I feel like this is the first step, maybe like a combination of like what like Google did with that pathfinding, plus like what Figure AI with OpenAI did, and maybe the Tesla bot. Maybe you put all these technologies together, and then we're gonna be able to have a robot maid, or like a butler. Like that'd be pretty cool. I'm excited for that. Like I want like a robot to be able to clean my house, cook my food.
Yeah. Bring back Rosie from the Jetsons.
Yeah, that's right. Yeah, exactly. That's exciting.
And I don't mean to downplay anything that they're doing. It's like seems like a really advanced engineering product that they have. They have to still rebuild everything that we're assuming is easy. Or
I don't think it's easy.
Assuming has been done already, even though it's been done before, like robotics from different companies. This is their first robot. It seems pretty cool.
So yeah, I mean, hats off to you, Figure AI. I'm incredibly impressed with what you're doing. Again, that factory tour, that'd be good. But anyways, yeah, I mean, like, sure, just because like another company's done it, like to put everything together, that is a hard problem in and of itself.
Yeah, that made me think about what Devin AI built too. Like their agent is really cool, but they didn't just build the agent. They built this whole UI. They built a web browser. They built a code editor, which in itself is something that entire companies do on their own. There's like companies that just focus on building a code editor. And, I honestly don't know why they went with that approach. If you're a startup, do you really want to rebuild the wheel as opposed to try to focus on what you're trying to solve?
I didn't realize they built their own code editor. I thought they were leveraging a code editor that already exists.
They might, yeah.
Oh, okay.
That's fair.
Like I don't exactly know, but it kind of looked a lot like VS Code.
Okay. That's fair. That's fair. I guess VS Code is open source, so they could have just plugged in parts of VS Code that's open source into their product.
I mean, I don't know. Maybe they built it themselves, but I don't know. To me, it looked really similar to a text editor that always there. So I would imagine, like, if I was going to build it, like, I'm not going to try to build my own text editor. I'm just going to, like, take one and then, like, maybe, like, it'll be, like, my own text editor, but it's just going to be, like, something that I've taken. So I'm just going to be, like, patching things together.
Yeah, that's fair. So it seems like there's a common theme in both these examples where they're both agents of some sort. They're taking these LMs that we already have today and then having them repeat prompts or like, answer something, reflect on its answers, and then iterate in that kind of an approach.
So, Shashank, when do you think we're going to get it where we have the robots building robots? I mean, like if we have the LLMs building software and then we can iterate on that software. So essentially software better than software. I want a robot to build a robot and iterate on the robots.
We'll have to bring someone from robotics to answer that question.
Yeah.
I think what do you need? You need data. You need training examples. We have a lot of that with software.
But you also need raw materials.
Sure. Yes.
Yeah.
I'm assuming that comes from humans somewhere.
Like, I don't know. Like,
a combination of humans and machines.
Aluminum, steel, like circuit boards.
You're thinking the entire supply chain.
Everything.
Everything.
I want everything. I want it to mine like the lithium that it needs with the better battery that it's going to create, and like the aluminum to refine it, just like
No jobs for humans.
end to end. And then like all of the humans could do something more fun, like go to Burning Man or something.
That'd be an interesting future. Maybe with some more universal basic income.
Well, yeah, it's something. I don't know. This isn't a politics show, but and also we're almost out of time, so I don't think. On that note, maybe next time we'll solve universal basic income, world peace.
Just sounds like
Yeah. Tune in next time.
Get one of these agents to work on it.
Yeah, we'll get on that. Maybe we'll
Sounds
get
good.
back to you. So, anyways, all right.
Until next time.
Yes. Thanks, everybody.